So today's going to be a little different from most lectures. So today we're not going to go through any slides. What I'm going to do instead is I'm actually going to go through example kind of data science walkthrough. So I'm going to try to solve some task. We'll talk about the task in a second. And I don't think these are necessarily the best kinds of lectures in general. I think doing a lot of like typing of code in the class is not that useful. But I'm going to give it a shot for one lecture. I think at this point we've covered enough material that it will be good to see how this is actually used in practice and how these actually kind of work, at least how I sort of tend to approach some data science problems. Before we do that, I guess there are a few still outstanding issues. So the auto graders are still having some trouble. I don't know what much to say other than we're still working on it. And we are going to push back a deadline because this has just been far too long at this point. So unfortunately, we can't push it back too much because it's end of the semester next Wednesday. But we'll push it back at least to Friday. And I know it's not a huge help because you have the project due after that. But hopefully you can get everything working locally, and then it won't be too much of an issue. We'll also try to be lenient with the grading. So if there are problems with the graders, we'll try to make them as sort of forgiving as possible. Okay, any questions about those? Yeah. Well, so the question was, should you avoid working on certain notebooks? So the notebooks that have graders are the MapReduce, the unsupervised one. The deep learning one and the probabilistic modeling one still do not have graders. I don't want to say you shouldn't work on those because they're good topics. And if it's a topic of your interest, you should work on it. And just trust us that we're going to get the grader up and working and not have issues. I can't, at the very worst case, you will just email the TAs with your notebook and they will just grade it manually in the worst absolute case. I hope we don't get to that because that will take a lot of time from them, but if it has to happen that way, it has to happen that way. So I would recommend working on the notebooks that sort of you find most interesting. Yeah. Yeah, some people are having problems with MapReduce Windows notebook on Windows machines. The TAs are also looking into that one. I also don't know what to do with that one. What I recommend there is there are clusters that you can use in the CS cluster pods that have Anaconda installed on a Linux environment, so you can use those to do the assignment if you need to. Yeah, we should actually post a note about that too, because there are public computers you can use to do those assignments, so that actually is worth mentioning. They're simultaneously trying to fix it on Windows machines, but I think there are some issues on Windows for some reason. Okay, so let's just jump right in. I think that there is some chance this will span a little bit of, actually a pretty good chance it will span a little bit of the next lecture as well. But I'm going to go through it kind of slowly. I don't want to rush things too much because I want you to get a sense of sort of what's happening and what I'm doing and why I'm doing everything that I'm doing here. Okay, so let's start off. And I guess actually I want to mirror my display. Okay. All right. Okay, so zoom in some. Okay, can everyone see that okay? All right. So the task that we're going to, and actually I should ask, is the video still recording? Okay, that video? Okay, that's good. Okay. All right, so the task we're going to think about is a analysis of products on Amazon. So as you've probably surmised from a few other mentions I've had, I have two young daughters. And their birthday's coming up. One of their birthdays coming up in a few months, so I want to get them a good present. And of course, like all good parents these days, it's very easy to outsource our actual physical shopping to Amazon. So I order everything from Amazon for them. So I want to get my daughter. She's going to be 1 year old in September. I want to get her a good present. And in fact, I want to get her sort of the best present that there is on Amazon. But I don't want to go with sort of the ones that are just sort of the typical presents either. I want to find her like an unusual present that's still really, really good. That's what I really want to find. So I'm going to go to the departments here. I'm going to look sort of for, let's see, where is it? Toys, there we go. Toys and games. Boy, they've changed all the categories here so much. Toys and games. I want to go for baby and toddler toys, just all those things. Do they not have, yeah, shop all baby and toddler toys. That would change the interface on me. And I want to go, she's going to be 1, so I'm going to select birth to 24 months. And I'm also actually going to only look at the ones that are that are have been rated 1 star or up, because I want to actually analyze the data of these reviews to determine what's actually 1 star or up. Actually, before I do that, I might actually go ahead and I forgot I was using Safari here. I actually want to be using, so I'm going to go ahead and quit Chrome and then restart it. Okay, so I'm actually going to go to Chrome on Amazon on Chrome. Let's start a new page and go to Amazon. Okay, so let's go to Amazon here. Let's go back to the place there because I want to actually analyze that page. Boy. Come on. Apartments. Very slow here today. There we go. Toys, babies, let's say. No, I want toys. I did the wrong one. Toys and games, there we go. And baby toddler toys, all baby toddler toys, and that age range. Okay, so I have my my toys here that I want to look up. Okay, so the first step of this is going to be to sort of pull this information in. But basically what I want to do is I want to start downloading, descriptions of these toys here, get a sense of sort of what toys are good, what toys are not so good, and do some analysis on that. So basically, download the description of the toys maybe, and the number of stars they get, the price range, the ratings, this kind of stuff. Okay, so we're going to start off this by basically, using our web scraping knowledge to scrape some of this stuff. So I'm going to do this. I'm going to go back to, actually I wanted to use Safari for this. Okay, so I'm going to just first of all start off with importing a bunch of my libraries. So I want to import requests. I want to import, import beautiful soup. I'm going to need pandas. I'm going to need NumPy. I'm going to need some plotting. And let's do matplotlib inline. Okay, so those are some of our libraries here. And let's set our URL. So I just copied the URL. This is the URL that we use for Amazon. And I'm going to go ahead and just query that page with requests, right? So my request response equals requests.get the URL. Okay. I actually know another library I want to use here. I want to also import IPython. This is a nice library for just sort of displaying things in IPython and Jupyter. Okay. So now I can actually do something like display as HTML this response.text. Okay. And unfortunately, something went wrong here. So let's see what happened. So let's just print what the text was. Okay. Okay. So to discuss automated access to Amazon. So they don't want me scraping their data, right? Okay. So if you encounter this, what you shouldn't do is you should not go ahead and email this address. In fact, it's sort of dangerous to say this on I know I'm being videotaped here, but you shouldn't email the address because they're going to take a while to get back to you, and they're going to ask all sorts of questions about what you're doing. So the right thing you should do actually is just start a new tab and say something like requests scrape Amazon, like in Python, right? Okay, so that's how you actually do this. Okay, and here's actually how I was doing it before. So you find the first Stack Overflow link you can usually. And what you'll find is that there's a nice little thing there to put headers in. So I have basically you fake your headers so that Amazon thinks that you're a normal browser, not a request library, and then you can actually download it. So I'm going to go ahead and do that. So I'm going to send my headers there. I'm going to say that now my response equals request.get the URL with the headers equal headers. Anything else? Okay. Okay, and now if I say display.html, my response.text, it should give me something that's like, yeah, the baby's there. Okay, so this is the best way to debug things when they come up. Literally just type it into a search engine. Okay, so now I want to start parsing this page, right? I want to actually figure out how from this page here, how do I actually get the actual content of these things. So I'm going to start by making a beautiful soup object. So the root equals beautiful soup. This is going to be a root thing of the response.content, response.text, actually. And it's always best, actually, when you're scraping stuff to use HTML5lib for beautiful soup. It just actually is a little bit more forgiving, and it parses HTML well instead of just libxml is a little bit more strict. So we're not going to do that. OK, so now we've parsed our object there. OK, and now I want to actually find these items on the page, right? And so the way I'm going to do that is I'm actually going to look here, and I'm going to look at, I know how to do this better in Chrome than Safari. But Chrome is a very nice thing where you can basically inspect certain elements here. So I can inspect this element here. And I can figure out, what's the sort of container that contains this thing. And it looks like, it's sort of hard to read, unfortunately, on the screen. I can zoom in a bit here. I forget if this also works to zoom in. Oops. OK, no, it doesn't zoom in that. OK, so what it says there is div.s-item-container. So I want to now, and that sort of is going to be, a similar thing is going to happen for all the containers there. If I inspect this one, it's going to be, I would bet under a similar div block in the page. And so I'm actually going to just start looking for this in my file now. So I want to say that my items are root.findAll, find all the divs with the class equals s item container. Okay, and let's just see how many items we have. There's 25, which is I think correct. That's the sort of number of things that actually came up there. Okay, so now let's look about actually trying to get the actual information out of here. So not just find the the block, but actually how do we find like the name of the item? How do we find the text of the item? How do we find the price of the item? This kind of stuff. Okay, so let's go back here. And now what we do is we basically go down and kind of try to dig deeper into this. In general, this is the sort of stuff that is you do once, but it's kind of fun to do. So here, let me see. We can sort of dig into this. Eventually, there's going to be a class that is let's see. It's a. I want to find like the link to the image. Say, oops, where is that? Okay, so here's an image. So the image, it's hard to read, boy. Let me pull this out a bit more and zoom in a bit more to there. Okay, so if you can read this, this is actually this is an image source tag there. And actually, this is going to be the main image source thing is actually in there. The rest actually are not image sources. So if I pull out the image source in that thing, I can probably find what that image is, or at least rather the link to the image. So let's look for example, items. Let's look at the first one, and let's find image, and let's look for the source then. Okay, so that's actually going to be now the link to that image. I won't bother. I mean, we can open it if we want, I guess here. It's the nice image there. I'll download that in a second, but for now we'll just sort of have the URL for that. Okay, let's find the other things now. So let's also now find, for example, the price would be actually no. Let's find the name of the item. That's going to be another important one. So let's go here. Let's look at this. Let's try to find sort of where this item is here. All right, so that's going to be not there, but going to be here. So this thing looks like that. It looks like it's called a link normal. I'm not sure if that's going to be the only one there, but this S-access detail page, I think actually is the key one there, right? There's X-access detail page. That's going to be probably the only class that's called that. I think that's going to be a link to the page itself. So if we pull out, say .find, it's a link. So we want to find a link where the class is XS-access detail page. And I want to get then the text that was actually appears in that. Okay, and so that's going to be the text now of the actual item itself. Okay, so let's do a few more of these things. Let's try to find. There aren't too many more. Let's try to find the price. So let's keep scrolling down here until we find something that has the price. The price is a little bit weird, I remember. So you could just keep drilling into the price. We'll find one eventually. Keep going. They actually separate the price out by the price whole and the price fractional. So they have two separate things for that. So you have to find the class, which is the price whole and the price fractional. But that's fine. We'll just go ahead and do it. So let's do this. Find, and it is also a, what kind of object was it? It was a span was the class. So we're going to find a span where the class is equal to SX price whole. And then we're going to find the text that's in there. So that's $3. And then the next one, I believe, was this weird like soup object for fractional. So let's find one of those. This is a soup, and it's price fractional. Okay. And so it's 388. All right, we're getting there. Let's find finally the stars. Not actually, I guess it's tomorrow. We're going to find both the number of reviews there's been and the stars it is, because if there's 5 stars but there's only 1 review, it's not that useful. If there's a lot of stars and there's 5 stars but 10,000 reviews, that's going to be pretty useful. Okay, so let's try to find finally the stars there. Keep going. Here's the stars. Dig in a little bit more. Here they are. This thing. Okay, and finally, okay, here we go. And finally, there's this span class that says a icon star, and that has this text. The stars are 4.3 out of 5. They're all going to be out of 5, so I'm just going to look for the first thing there. Actually, I'll just get the whole thing. So what is that? That is that is one of these weird like I things, like an image for like non-image things, but I don't know what the -I thing is. It's some kind of image that's embedded. So I want to find an I thing called a icon star. And look at the text for that. So this is 4.3 out of 5 stars. And finally, let's do the number of reviews. This one I remember being kind of tricky. The number of reviews is this thing here, so let's try to find that. Okay, it's going to be in there. It's this thing. Right, so it's this text, which is a link, a hyperlink. But the only way I know how to find this hyperlink is to look at hyperlinks that end with this hash customer reviews in the end of the link. So I'm gonna look for the links that end with this customer reviews in that field. So let's see if I can do this last one. 0.find. Okay, I want to find the links where the reference for the link. Oh no, I have to do this weird thing where I actually want to have a filter for this. So I'm going to say the thing has to end with this hash customer reviews, right? So that basically creates a filter such that only the things that end with this customer review tags will pass, and so it'll only get that one. And then finally, I want to get the text that's actually in there. So I want to get the text. Okay. Oops, I printed this twice. Okay, so now I have the number of reviews too. Okay, so a few more little things we can do. We might want to, for example, I guess we can also get the image itself. So let's actually figure out how to pull this image. That's going to be easy. That's just I think we don't even need the fancy headers here. No, probably we do actually. So let's try to get this thing, the first source there. Headers equal headers. And let's call this the response to equals this. And then we can display images in the notebook with this display.image call and the response to dot content should be the thing to display. Oops, what's going on here? What did I do? Sorry, say this again. I got all the people talking to me. Oh, press get. Oh, whoops. There we go. Where is the Reference.get. Okay. Okay, there we go. There's our nice little image we have. And I guess we can do a couple other things. So in addition to doing this, we'd probably want to do things like not only find everything. This will give us, obviously items here. If we look at item 1, right, that would just give the next item. So it's the next item on the page. That was that banana toothbrush. We have that one actually. I wonder if that's actually incidental or not. I think even in the private mode, it knows that I've bought that. Actually, we bought multiple ones. Okay, so the other thing we might want to do with this, right, is actually, so this will give us sort of all these items that are on this page, right? But we also probably want to look at the next pages as well. So we also can look at things like what are, what other pages are there. So if we inspect this element here, we can find the link to sort of the next pages that actually show up from this. So let's see. So it looks like the current page is into this page current thing. And this page next is all these things that are under this page class of page and link is all the next sort of pages we can get to. So I can basically get to page 2 and page 3, et cetera, by following these links. So for example, I won't do this too much, but basically if I look at something like, let's see, if I said something like, let's see, so root.findAll, it was a span object, right? It was a span that said page link. I guess I want to find what the actual link is there. So it's the actual link within that is the actual link to the next page. So I want to find span where the class is this page and link. And maybe I want to say x.find the link. I want to find the actual link, which is the reference, the hypertext reference for x in that. Okay, so that'll give me now all the subsequent links. This gives me page 2, page 3, et cetera. And I can build actually, a table of all these pages. You can also kind of guess what they look like, right? They basically have, you can guess what this is, but I can also sort of go the pages one by one and actually find the next one at every point and go to the next page. So that's how you sort of both navigate away from the current page and find out what the next pages are. You can also look at the page current for what my current page is and only go to ones after that to find out what the get the number and only go to ones after that to find out what the actual thing is. And I think I'll give a few examples of that in the notebook I put up. Okay, so the point is. I don't want to spend any more time scraping stuff. I think you get the basic idea, right? So this is sort of how you go about collecting data. You kind of analyze the page. You input the stuff on Beautiful Soup to figure out what you want. There are other libraries, I should say, that do this by default. You kind of just say that things like scraping and stuff like this will actually do this by default. But I think it's actually kind of nice to do it manually. It doesn't take too much time, and it can kind of be a good exercise to go through these things and store them in some file. Okay, so what I did now. So this is sort of I did a couple stuff offline here because I don't want to actually scrape them all in real time. It takes a little while. If you do it too fast, Amazon will actually ban you, and then it's actually they ban your IP, and so it's kind of a pain to then get reinstated and do that kind of stuff. So what I basically did was I put all that, I bottled that all into a script that I ran on a machine overnight. It downloaded basically all the images and all those features essentially for the images, the names, the stars, the price, the rating, of course, for all the different items in this category here. And I traversed the pages for each page, finding what the next pages were, looking at my current page and only going sort of for the one next page at each point. So I would just do the first one here. Actually, I would just do this. I would just always follow that link to the next page and keep building this. Okay, and then I put them all. I probably should have put it in a database just to be safe, to sort of be a little more like the class. But I got a little lazy. I just put it in a big pickle file. So I just dumped these in one by one as they came. I just sort of dumped them to a file. And I put this in this out.pickles file, which I'll include with the notebook here. That way you don't also have to scrape everything. You can just start using the data as we got it. So okay, so I'll just actually write the code how I parse this now. So I'm going to put all the items I get into this all items array. There's actually going to be a dictionary where this is going to be called, the actual image data itself will be called, well, you'll see in a second, but it basically is a dictionary. And I actually ran into one problem too, which I'll mention here. So this is output.pickle. I'm going to read it. And then while there's stuff left, so I pickled first the URLs of the different web pages so I wouldn't scrape any page twice. So I would only scrape the pages sort of incrementally. If I'd already grabbed that page, I would do it because the script crashes sometimes. And so if it's already scraped the page, I don't do it. I just basically saved a list of all the pages I had scraped already. So this is how I do that. This is not going to be very useful, but it's how the pickle file is created. So I have to do this now. So load from F. Okay, and then all items. So I'm going to add to my list of items .load. Okay, and then if this breaks, it'll throw an exception, and so I just exit the loop here. Okay, so I'm going to run this, and then what was that? Pickle. Pickle, yeah. Actually kind of weird that it ran, huh? Oh, look at that, it's empty, see that? Okay, so what happened here was, and I'm actually just including this because I thought it was, this happened this morning and I was trying to kind of panicked like it was gonna have to re-download everything. But I ran the script on a machine that had Python 2, not Python 3. This is Python 3 now. I don't want to make you all, I didn't want to run my tutorial here in Python 3, so as another illustration of what you do when these things happen, you say, Python load pickle file from Python 2 in Python 3, and I'm pickling a Python 2 object with that. And what you sort of find is you have to have this, you have to specify an encoding. So Python 3 has a difference between sort of string objects and byte objects, which we won't get into, but this is what you have to do. So I'll do this, and then now this should actually work. Okay, hopefully this works. Okay, so now, why is that not working? All right, I'm going to try this. Oh, sorry. It's actually, sorry, the encoding should not be Latin. The encoding should be bytes, is what this actually says to do. Where was this? Oh, how did I? Yeah, so encoding equals bytes. That actually is more forgiving, because some of the things actually are bytes here, and some of the things are, like the images are actual bytes, and other things are strings, so we do it this way. This should hopefully work. It doesn't seem good, though. Okay, now I actually don't know what's going on. Output.pickle, pickle.load, F. We also append pickle.load, F, encoding equals bytes, encoding equals bytes. Let me just do this one time and see what's happening. Oh, that's okay. All right, and I had this in this weird try except because that's how I was doing. So that's probably actually a pretty bad coding pattern, but now I'll do this. Okay, so now it actually works. So the one thing I have to do now is to notice that so this is a dictionary now where the keys are the data, the name, the link, the price, and the ratings, the link, image link, the link itself, and the stars. One thing you'll notice is that because of this weird loading, it actually loaded them as byte objects. So the way you break out of that is you have to decode each of them with some encoding. Don't worry about this. This is another thing you can look up. I won't show you the fact that I looked this up also on thing, but basically on Stack Overflow. Actually, no, we'll do this. It's a Python 3 bytes to string. And you'll see convert bytes to a string. And what do? Okay, you use this decode UTF-8 if it's UTF-8 string. Okay, so let's decode with a UTF-8. And the value for KV in all items for KV in item.items, and then for item in all items. Okay, so this should be now a conversion back to the old thing. And in fact, let's also go ahead and just build a data frame from these objects so we can look at this. Okay. All right, so let's now look at our data frame. So this has, the image data is the first thing, the image link, the link itself, and the ratings, the price, the number of stars, et cetera, in some order. Let's again look at the first one here if we want to. So the image data is this set of bytes here, image link, the link itself, the name, number of ratings, price, et cetera. Okay, so now we have our data set that I'm going to use to try to classify what we want to do. And the first thing we're going to do, before we do any sort of real classification, remember sort of there's a few things. First of all, I sort of talked yesterday about debugging, or last lecture about debugging data science. But I also sort of said that before we actually really do much of any kind of real predictions or analysis, we actually start by visualizing stuff, right? So I'm going to both clean my data a little bit, and I want to clean my data a bit, and I want to visualize sort of what this actually looks like. Okay, so let's switch gears now. I have my data collection, so our sort of data collection. Oh, I meant to put a section here, so let's go ahead and just name this section data collection. Okay, so now let's talk about some, basically some visualization and cleaning. All right. Okay, so the first thing you'll notice is that we want to actually do things like, the number of ratings right now is a string. It has commas in it. So let's first of all make that a floating point number. So I'll do it like this way. So num ratings dot apply x dot, and then I say something like float x dot replace the quotes with that. Now, num ratings should be something reasonable. Oops, num ratings. Ugh. Let me just reload that. I don't want to have too many spurious things there. Okay, so now num ratings are actually floating point things instead of other ones. I can make them integers, of course, too, but whatever. Same with stars. Stars says 4.7 out of that, but we just really care about the first thing. So let's go ahead and just set the stars to be equal to the stars. Let's just look at the first thing there. So that would be something like stars. So it would be like x dot split and then 0 thing, and I convert that to a float. Something like that, right? Nope. Oops. Yeah. Can't do both of them. That's the danger of this. So okay. And let's finally let's actually also make so stars is kind of a weird object. So one thing I also did here is I set the rating to be equal to stars minus 1 divided by 4. So it's now normalized between 0 and 1 instead of between 1 and 5. So let's just do that. Okay, I'll put this back up here just so all our pre-processing is there. Okay, so now let's do a little bit of sort of easy visualization of these things. So let's look at, for example, how many ratings there are for the different products. Okay, so let's look at for our get a sense of how many times there are, a histogram of how many times a product is rated. So let's look at the num ratings. So this is the number of times rating, not that they're actually rated, so this is the num ratings. I should say I'm going to post this whole notebook online afterwards, so despite the fact that I should probably take out that line on the header line on how you scrape Amazon. But okay, so yeah, so you don't have to worry about writing this down or anything like that. You can just sort of follow along. And let's say 25 bins or so. Okay, so here's our histogram of the number of ratings. So as you can see, not too useful, right? Because basically most things are rated one time or a very small number of times, and there's a very long tail here of of things that are rated more times than that. So this is probably not very useful to sort of look at the raw number of ratings. So one thing that's sort of common here is we actually look at the log of the ratings. So let's look at the log of the ratings themselves, and that's going to be hopefully a much more useful thing. And actually, even in log space, this falls off kind of pretty rapidly, right? Maybe, I don't know if it's exponential or not, but right, it falls off pretty rapidly, right? So there are really, really few elements out here. I mean, this is a big, big difference. This is 10 to the 3. This is 1, and there's a big, big difference in that, right? So there's a lot of things that are rated 1 time, a couple things rated 2 times. This is actually probably missing value. There's no value here. This is probably rated 3 times, and then you have a very long tail on the number of ratings. So this gives you some idea of sort of, the things that are out here are all going to be pretty popular, but those aren't the things I'm looking for, right? I'm looking for the things that are down here that we sort of don't even know that are good yet. So we're going to go after those ones. Okay, so this gives us a sense of kind of the number of ratings. It also suggests that, maybe if we're sort of looking to train a model here, we shouldn't really worry about things that have only this many ratings, because they're not going to be very reliable, right? They're going to be sort of one rating that says maybe 5, or one rating that says maybe 1, but it's not going to be a great sort of metric for how popular they really are. What we really want to do is look at things that have been rated a bunch of times and figure out kind of what the popularity is there. Okay, so let's now to do one more thing. So let's also look at the histogram of the ratings themselves. We'll also do bins equals 25. Okay. Okay. So this is also kind of seems to be a little bit tailed towards that. So that, a lot of things have a rating of 1, but we don't really know from this view, how, for these items here, they could all be ones with 1 rating, right? They could be things with 1 rating. So we probably want another different kind of view of this data rather than just looking at all the ones with 1 rating. We want to have some sense of what this actual distribution looks like. So a nice thing we can do here is actually do a scatter plot of the number of ratings. Actually, you probably want to do the log 10 of the number of ratings with the rating itself. I think this is a pretty useful figure to see. Okay, so here's the figure that I think we actually probably are the one that we care about. So this is a plot of the rating itself, and again, we've normalized between 0 and 1, and the number of times in log scale it's been rated. So an interesting thing here is that things that have a lot of ratings, for the most part, are actually rated pretty well. People tend to rate things pretty highly, and so in general, we sort of have a bias towards things that are rated highly. And so this suggests we actually want to do something that's a little bit interesting here. And I'm going to make some kind of somewhat ad hoc decision here, but I think it kind of makes sense. We talked a lot about sort of this notion of like Laplace smoothing, right? For when things only have a small number of observations, you kind of want to divide by kind of like a mean average. So you add 1 to the denominator, divide by 2. This actually can be viewed as, and this actually can be viewed as actually sort of a Bayesian model for assuming that we have some prior knowledge. So essentially, if I assume that we have 1 rating for everything, that's actually exactly just a 0.5. We can actually create a little bit different version of their rating, where I basically, I got the rating by, basically I can make our rating equal to the rating we observed times the number of ratings plus 1 divided by the number of ratings times 2. And that kind of gives me like a smooth version of the rating. And I'll show you what I mean in a second. Okay, so I'm going to create this sort of scaled version of this rating thing here. We're just going to kind of compress this side here by basically adding 1 additional review that's kind of like a 0.5 or something like that. So I'm going to add I'm going to call something called create a new column here called my Bayesian rating, which is going to be equal to my rating times my number of ratings plus 1 divided by my number of ratings plus 2. Okay, so basically, if it's 0, if the rating is 0 there, it'll go to 1/2. If it's sorry, not quite. It'll go to like 1/3 because you still count the 0 rating and just add 1 more rating. If there were no ratings, it would be a rating of half. If it has 1 rating of a half, it'll stay at a half. If it has 1 rating of 0, it'll be 0.25. If it has 1 rating of 1, it'll be 0.75, etc. Okay, so this is going to be my new Bayesian rating. And I can also actually plot this thing now, and it gives, I think, a little bit better view of what we actually care about here. So basically what it does is it shrinks all this a little bit towards the 0.5. And those differences are actually important because essentially, for this space here, for all those spaces here, we only have maybe 10 ratings of all those ones up there, and they're all just happen to be all 5s, which is not the best sense of like the most popular thing, right? Because if they have 10 ratings and they're all 5s, people are pretty generous in their ratings in general. I mean, they're, clearly the 5 stars was the most common rating we saw on Amazon. And so, with little peaks around all the others as well, some around always, 1 rating of 1 star maybe. But basically, we want to smooth this a little bit. And so creating this sort of smooth version where items with a very few ratings sort of get averaged out towards 0 kind of is a sensible way of doing this. This can be viewed, by the way, as putting a prior on your rating and treating the observations as sort of informing your posterior over your ratings, but we won't worry about that. Okay, so let's look at a few other things. Let's look at things like the price. So how much do these things actually cost? I forget if actually is price already a floating point? Yes, it is. Okay. It somehow knew price was already a floating point. Maybe I did that when I was first scraping. Okay, so let's look at the price that we see. And this we don't want to do in a log scale, right? We can probably consider this as being pretty reasonable just to do as it is. And in fact, I actually, let's see. Okay. If we just try to do this, something will happen here. So what happens is that there are some prices that actually are not filled in Amazon. So if you remember Amazon, right, sometimes you'll click on a link and it says like you can't see the price until you add it to your cart or something like that. I didn't actually go here and add it to my cart, so there's some number of things where I can't actually see the price. So I'm going to eventually throw those away. I don't really care about the ones where I can't see the price. But for now, let me just sort of say, so I'm going to say the price for all the ones where the price is not null. I will drop all the price ones where it is null in a second, but let's just do this for now. Okay. Unfortunately, it actually looks like this is a similar thing. So I was thinking that the prices wouldn't actually be so bad. Maybe the prices are more normal, but prices also seem to be have a very heavy tail. So let's also do a log transform of the prices themselves. So let's look at the log of the price. Okay. And this now seems much more normal. It's sort of a nice, it's not quite normal. There actually are some things that are like $300 here, or I guess, almost $300 for baby toys. I don't know what those are. We actually could look. Let's actually see what the thing is. So let's look at what the max. Actually, I want to do argmax. I actually forget how you do this. Okay, well, df. I'll do it the silly way. Price equals. Okay, so this is a submarine wall panel, which got 4.3 stars with 3 ratings. So not many people bought them. So yeah, I can see this. Well. I'm just curious now what this thing actually is. Okay, it's I think it's actually giving me the thing. Let's see. Link. All right, let's see if I can figure out what this wall panel is. Okay. Oh, that looks actually kind of cool. That would be. Oh, look, it's come down in price a little bit. Look at that. It's now only $478. 3 customers really liked it. Okay, so that was more for my benefit than anything else. I'm curious what the most expensive baby toy is that I could possibly get. I think I'll avoid that one. Okay, so the one thing we can also do that I think would be nice to look at is sort of visualization is does bigger price actually correspond to higher or lower ratings? So do people like expensive things more or less than not expensive things? So let's first actually go ahead and just actually I think let's just say I don't know. Yeah, let's just do this. Let's just drop the bad ones where the subset. Sorry, was something? Comment? No, okay. So let's drop the ones that have the price to being some a null value, and now we don't have to worry about these null prices anymore. Let's plot the price, but really the log of the price. And against the Bayes rating that we have. That's our rating that we trust here. Okay, so oddly enough, there doesn't seem to be that much correlation here. So some people like really low price items. I guess not really like the lowest price thing. This must be like 20 cents or so. Doesn't have very good ratings, but there are some pretty good ones right in the mid price range. Maybe I should check out which ones those are. but doesn't, I mean, and there certainly are some ones, but I mean, there's some really bad ratings here from really expensive things. So I think this one was probably like up there or something like that, but there are some really looking, doesn't look great for expensive items, expensive baby items, which I think probably makes sense. Okay, so I'm also going to, just now for my own sake, I'm going to sort them by their Bayesian score. Let's see, so where's that? Sort values is what I want. By equals, oops. Sort them by their Bayes rating. And I want to do in place equals true. I also want to make the highest ones first, so ascending equals false. All right, so I'm going to sort them, so now they're sorted. And the last thing I'm going to do for the purposes of the further analysis is I'm also going to only look at things that have more than 4 reviews. Sorry, more than 4 ratings, right? I'm now going to switch to kind of the analysis of the actual data itself. And so for that purpose of that, I don't want to look at the things that only have 1 or 2 ratings. It just isn't that useful for predicting. Even with my Bayes score, that maybe is helpful. I still want to do it for the low ones, but these are just with 1, 2, 3, and 4. They just seem like there's just too many of them, and they're not going to be that helpful anyway. So let's just ignore those and really do our analysis on things with more than 4 ratings. Okay. All right. So now. That was sort of a first take on some basic kind of data analysis you can do on these types of data. And actually, this is sort of hopefully a good template for the kind of analysis you want to do in your own project, right? And the kind of scraping you might want to do as well. This kind of stuff serves as a really good way to get familiar with the data, get a sense of what the data actually looks like, and kind of get a sense of what's going on in your data set. Okay, so now what I told you to do in the lecture on debugging machine learning is that before you do any machine learning, you should see if you can solve your task right away, right? You should see if you're able to solve your task. So in other words, you can make like a game and say, okay, can I predict, say, the rating from the description of the item as far as I've given it myself? But I know you're not going to do that, actually. What you're going to do first is you're going to just try to apply some machine learning and see if it works or not, because that's what we all do. So I'll go ahead and do that now, too. So I'll sort of do this, first like rarely successful take on machine learning. All right, so I'm going to treat this as the goal for me is going to be, can I predict what the rating is, or what say the Bayes rating is, as a function of the other features of these things. So maybe I'll take like the words. What the features are. I haven't defined what features are, but maybe I'll take like the price could be a feature, the number of ratings you get could be a feature. That one maybe is cheating because I actually limit myself, so maybe I'll leave that one out, or I'll see if it's useful or not. Or see if I want to include it or not. But also do things like maybe TF-IDF vectors on the words in the description or something like this. I'm going to try to predict from that what the rating of this item is going to be. So let's sort of look at that again. So let's sort of now look at this Bayes rating as we have it, and this is our Bayes rating. That's the thing we want to predict, and one thing that kind of is immediately obvious here is that this distribution is really not very Gaussian, right? This is sort of highly non-Gaussian, this distribution here. And so it's not really clear, like, if I try to predict with like linear regression, it's not really clear that I'm going to be successful, right? Because linear regression, as we know, tries to fit a Gaussian distribution to this data. I want to give myself kind of as good a chance of succeeding here as possible, and I'm going to focus on kind of what I would do in a regression setting. But the problem here is that this doesn't seem to be Gaussian. And when you're trying to predict data that's sort of highly non-Gaussian with least squares, say, you often kind of do poorly, right? You often don't do all that well. So I'm going to do a couple sort of tricks that sort of typically come in handy to deal with this kind of thing. But actually, the one thing I'll do first to illustrate this is I'm going to use something called a QQ plot. From sort of a common statistical plot that basically shows how these points are laid out with respect to an actual Gaussian distribution. So I forget what library this is in. I think it's called scipy.stats. Yeah. So the library to use here is the stats module in SciPy. And the plot I'm going to make is this thing called a QQ plot. So first of all, I need to standardize this variable. So I need to sort of take the Bayes rating, subtract its mean, Bayes rating, and divide by its standard deviation. Bayes rating. So this is now, a normalized one, but we know it's not going to be any better, right? It's still going to look like the same thing, just that. Okay, so this is now a histogram. It's just a little scaled version with zero mean and covariance and unit variance. And I'm going to do what's this thing called a stats, and the function for it is prob plot. So I'm going to plot basically the distribution of these points versus a normal distribution, what it would look like, which you'll see in a second. And I think I need this key there. Okay, so this is what's called a probability plot or a QQ plot. The idea is I look at the sort of the quantiles of my data and I plot them on sort of this x-axis, and then I also plot the actual observed values that I see for these quantiles on the y-axis. So the point here is if this data was normally distributed, these should lie exactly on a line, because this line is the quantiles of the normal distribution. And of course, the theoretical ones are the same as the observed ones in a perfect normal distribution. But what's happening here is that, essentially because the data is not normal, right? Because we have a much shorter tail on this side than a normal is. The data, in fact, is limited, right? So and maybe a longer but also a truncated tail on that side, we have this weird effect that the data just does not look very normal, and this is evidenced by the fact that this thing lies very far from this line here. These are not perfect, by the way, these probability plots or QQ plots, but they're sort of a good example of sort of an easy way to test if something is normal without, just sort of visually, without like, hypothesis testing for something being normal or not, because that's very sort of abstract. These things are sort of a very visual, quick fit to see if it does seem normal or not. Okay, so having done that, I'm going to transform the data now to be try to transform it to be a little bit more normal. And so a common thing to do when you have data that is between 0 and 1 is to form what's called the function is called a logit function. And basically, if I have a p, which is a number between 0 and 1, I can take p over 1 minus p and take the log of this, and that's called a logit transform. So I'm going to take the logit transform of this. That transforms it basically, obviously p here is between 0 and 1, but this quantity here will be between negative infinity and infinity. And it sort of is, between, yes, between negative infinity and infinity. If it's as it goes to 0, it'll be negative infinity. As it goes to infinite, it'll be infinite. So what I'm going to do is I'm going to take the log. So I'm going to create a new rating, which I'm going to call my logit rating, which is going to be the log of the Bayes rating divided by 1 minus the Bayes rating. Okay. Actually, before I do that, let me do one thing. Okay. So now let's look at our histogram of these logit ratings. And this, by the way, is sort of a common thing that I would recommend doing. If you have data that when you apply the histogram is just not normal at all, think about the transforms you can apply to make it more normal. So if it's has a huge heavy tail, like we saw before, do something like take a log transform for like this. This may this one here therefore might be more like exponential. So use the exponential distribution of taking a log. This one, hopefully after taking this logit transform, it's going to be a little bit more normal. Let me set some more bins. Okay, so this looks a little bit better. That's certainly not perfect still, but it looks like we might have a chance of this actually being somewhat like a normal distribution now. And in fact, if we run a QQ plot again, so let me do this same thing with the logit rating. They call it prob plot here. Let me do it with the logit rating though. We kind of see it as expected. This looks much more like a normal distribution, right? It fits the line better. Just everything seems a bit more normal. It's still not perfect, of course. So we still have things that are not. The tail is not that heavy here. There's some things that seem to be shorter than the Gaussian tail, but it seems sort of okay. Okay, so this seems like a better sort of thing to predict than the raw rating, because we know that least squares, if we're going to use least squares, say, we know that least squares is going to predict, based upon a normal likelihood, and so we have a better chance of succeeding. The more our data actually is normal in its marginal density, the more likely we are to succeed. There's a question there.
Why does using the logic transform?
So it isn't obvious why it would. The best way I can sort of think about it is that if you think your data is normal, so if you take normal data and apply the inverse of a logic transform, which is actually the logistic function, that gives you things between 0 and 1. And so if we believe our data is normal in some space and it's been transformed to these ratings, which are in some other space, which actually in this case would just be a logistic function. So if we believe that ratings come from something like a logistic model, where they're normal in some space then transform with a logistic model, then the logic transform would actually make them normal again. So that's, again, I haven't justified why that should be the case, but that seems actually like a pretty reasonable assumption in practice, and so we get things that are much more normal. When you have probabilities between 0 and 1 as your sort of, or quantities between 0 and 1 as your observed variable, doing this transform is a common way of putting them back into a more real valued space. Okay, so now let's go ahead and do some machine learning. See how well we can predict this thing. Okay, so I'm going to create the TF-IDF vectors. So I'm going to create some feature extraction, and I want to create text, import TF-IDF vectorizer. Okay, so TF-IDF, let me just do this. IDF equals TF-IDF vectorizer. I'm going to, I can specify a few things here. I just messed around with the guess initial value. So I think we have to, so the document frequency has to be 10. So we're only going to consider words that are in 10 or more names. What we're doing here is we're creating TF-IDF vectors on the names of these items and try to predict the reviews or the score from the names there. So I'm going to have at least 10. I'm going to say the max document frequency should be, I think if I specify, I forget, it can only happen if you specify a fractional thing there, it has to happen in only at most 30% of them. So if it's like V or A appears more than that, it'll drop them. And I'm going to use n-grams of size 1 to 3. Okay, so I think that works good. So I'm going to create 1 grams, 2 grams, and 3 grams. Okay, so now I say x TF-IDF equals TF-IDF dot transform, fit transform, and I'm going to do the name, and I'm going to make this an array. And TF-IDF. So this creates now makes this big, that has this many words in it that appear that often. I won't worry about what the words are. We'll get those in a second later. So okay, so now our final matrix X here that we're going to use is going to be, I actually don't want to use the number of ratings to guess what the rating is, because we already see this as sort of very kind of, so it's kind of artificial, right? We already see sort of this, and the reality is the whole point of this is we want to predict what the ratings would be for a new item that doesn't have any ratings, right? So we can't actually include the number of ratings as one of our features, because we ultimately want to apply this to things that don't have any ratings, have 0 ratings, right? And that would then not be applicable, our classifier anymore. So I'm going to create a classifier that basically looks at features that depend on the TF-IDF features and then also the price. And because the price is this weird least trivial scale thing, I'll actually even include the log of the log of the price as my feature. So it's going to be a matrix that has X, TF-IDF, and the log of df, the price. Okay. And I'll make that values converts it to an array itself. Okay. Oh, I actually need this to be I have to do this to make this a 1 by whatever array, so that I can should do that. Okay, so that's our input. That's going to be our feature vectors, and then our output is going to be, let's make it the logit rating. That's what we're going to try to predict, and the NumPy array for that. Okay, so now let's actually just go ahead and fit these classifiers. Before we do that, though, I have to create, the train, testing, and cross-validation splits. Scikit-learn, I'm not going to do this in any sort of detailed way. Scikit-learn has a nice little function for creating these things, for doing train test splits. So I'm going to say x and x test here, and then y and y test is going to be train test split of x, y. Test size is going to be 0.3, so I'm going to hold out 30% as a test set, and I'm also going to specify a random state, and that makes sure that this is repeatable every time. Now I'm also going to say my train and cross-validation are going to be the split of what's remaining there. So my train and cross-validation and my y train and y cross-validation are going to be train test splits of x, y, and test size equals 0.3, and my random state also is 0, say. All right, so now I've created my training, testing, and cross-validation things. So remember, I'm not going to do much cross-validation here, but eventually we're going to do like some hyperparameter selection for these things, and I want to make sure that I want to make sure basically that I'm able to do sort of hyperparameter selection on my cross-validation, not on my test set, of course. Okay, so now let's pick kind of a regressor to make these predictions, right? And we could do, we could do anything we want. We could just do linear regression. We could do whatever we want. I'm actually going to use, typically, if you're doing kind of a one-shot thing, it's good to try both something really simple and something kind of complex, just to sort of see what the possible range of performances is. I'm only going to show one here, because what you always do, of course, is you use the most complicated thing twice. Again, this is a first. I'm going to highlight again. This is a rarely successful method for doing all this stuff, but let's use the most complicated thing that we would ever use, which is like a gradient boosting ensemble or something like that. Import gradient boosting. Let's sklearn.ensemble. Import gradient. Is that they changed? That's this called boosting regressor. There we go. That's why it was working. Okay, and let's set our classifier, or let's set our model to be equal to gradient boosting regressor, and let's just do. I always call this. I use a classifier for this. I was going to try to use model on the fly, but let me just do this so I don't mess this up. So I'm going to fit this to my data, and it'll take a little while because it's kind of a complicated thing. But now it's trained to fairly sophisticated. It's still using mean squared error as the criterion. This is how the regressors work. The loss is least squares loss, so it's still sort of. The likelihood is still kind of a least squares law, so it's still good to have Gaussian outputs there. You still want to do that, but this is now a pretty sophisticated nonlinear classifier. That's a good first pass at a lot of these things. Okay, so let's look at what the training. So let's look at the training MSE. That's going to be the mean of the prediction predict of x train minus y train, that thing squared. All right, so let's see what the training, let's see. Okay, so the training MSE, so we get it, our squared error between our prediction and our actual is, 0.36, which is, is that good? I don't really know. We could certainly try to drive that down by these things, but we don't expect to get 0 here, right? Because we expect that there's going to be some variance that we're never going to really get rid of here. This is fundamentally a stochastic problem, and so we expect I wouldn't expect to be able to get 0 error even on the training data here, because probably for a given set of title words, you could either have a higher rating or a lower rating. There isn't all that much information actually there. So that seems like a reasonable thing. Let's look also at the performance of a with some baseline. So baseline training MSE would just be, instead of predicting the actual prediction from this, we just predict the mean of Y train everywhere. So remember, another really important point is whenever you show results this is good. I mean, is it good? I don't know. Maybe it's good. It's hard to say, right? The way to contextualize any of these things is to show the results against some simple baseline. So when you're evaluating least squares error, you want to evaluate against, well, what happens if I just predict the mean as my output? That's the one single quantity that will minimize the squared error. But, if I had to predict one number for everything, that we would predict the mean for that. And yeah, it's 5.7. So it seems like you actually are doing a little bit better when you train your classifier. Of course, this is the training set is the problem. So let's see what happens on the test set, on the cross-validation set. So baseline CV MSE, CV, and let's look at the XCV minus YCV. Okay, so unfortunately, when we now move to the cross-validation set, it doesn't seem like we're doing all that well anymore. So basically, we started off, we just picked the mean everywhere. We get, on the training set, we pick the mean from the training set that is on, on the cross-validation set, we get 5.6, and our improvement seems to be kind of marginal over that, right? So, it doesn't seem too encouraging there. And, you shouldn't do this until the very end, but since this is just not a real, and since I know you will, let's just go ahead and look at what the test error is too. We haven't really done any hyperparameter optimization, so we're sort of okay doing this. But actually, it's even a little bit worse, right? So that's part of it. Is just our test set is sort of seems to be kind of hard here. But this doesn't seem like a super promising result here in terms of what we can do. Okay, so now in the time I have left, I want to sort of go back to what we should have done at the beginning, which was play a game that sort of tells us whether we can solve this problem or not. So I'm actually going to play a game where I basically have to guess what these ratings are and see how well I can do, right? Because we expect again that classifier probably can't do better than me. Now the one caveat there, so I'm going to talk about like playing a game. The one caveat there is that humans are really bad. Even when we can solve a task, we're really bad at predicting numbers. So we're good at predicting classes, like yes, no. We're really bad at predicting numbers. So the thing to do if you want to tell if you can solve like a numerical task, if you have any hope of doing that, is to not actually try to predict the numbers yourself, because that's going to be essentially impossible for you. But instead, try to predict the relative ranking of two items. All right, so what I'm going to actually do is I'm going to look at two items drawn kind of randomly from my data set, and I'm going to say, can I tell which one is rated higher, given all the same information that I gave my classifier? I'll even actually look at the images too. We can look at the images maybe. But the question is going to be, can I actually do better than random chance? So let's look at first, I have a little function here to display an item. So display.display. Just image data equals s image data. This is just a quick routine to display these things. And I'm going to print s name, and I'll print like the price string s price around to 2 digits, I guess. Okay, no, 3. All right. Okay, so let's then display item. Let's do df. Okay, this is actually the one that was rated the highest in our class. I sorted, remember, by score, so this is actually the highest rated toy. But again, I want to look for the ones that are, this was rated like 60 times. I want to look for the ones that are a little less well known than that. Okay, so now let's play our game. Let's call this like the ranking game. And what we're going to do is we're going to select two items at random. And in the length of df, and we're going to have remember the one that's lower of these two is always the correct one because they're ordered by list. So the one that's lower index is always the one that's higher rated. Okay, so I'm just going to display the item df dot lock one maybe I'll like print some 2. Okay. All right, and I am going to also now get my guess. This is going to be an integer, which I'm going to. This is input function in IPython, in Jupyter Notebook. Lets you input. So it'll pause until you input a number. So which item is rated higher? 1 or 2? 2. Okay. And you'll input a guess on that, and then the true ratings. Also, I'll print the after we're done. After we've gotten that, we're going to say the true ratings are true ratings are going to be. So this is for parts 1 and 2. df 1. Oops, it 1, and then the Bayes rating. And okay. All right, so it's going to print the. Oops, I want to do this. Sorry, I want to do that format. Okay. And then, like, are we correct? That would be, well, we're correct if our guess equals 1 and, oops. Okay, we're correct if our guess equals 1 and this one is less than that one, right? Because that means that rating is higher. There's, I'm sure, a better way of creating this conjunction, but I'll just do it this way. Or if our guess equals 2 and this one is greater than that one. Okay, so that's how we know if we're right or not. And we can say, you know, print, let's say, let's just say format correct if correct, else incorrect. All right, and here's our game. All right, now let's play the ranking game. All right, so this is now our fun interactive poll part. Who thinks number 1 is higher? Okay, rainbow blocks. Who thinks number 2 is higher? Okay, so number 1, that was a thing. We're correct. All right, that was actually a good. This is way higher than that one. So, all right, these two, the assorted color camouflage rubber duckies or the Waka Croc wooden toy. Who thinks the Waka Croc wooden toy? Who thinks the other one? The rubber duckies? Incorrect. Sorry, the rubber duckies are actually higher. This one is not rated very high. Okay, who thinks the Thomas the Train things? Who thinks Thomas Train? Who thinks stand to sit to stand alphabet train? Okay. I don't really know what was doing there. I guess we're getting hard here. I think let's see. So I would probably guess number 2. Okay. They're both kind of high. Let's see. EduShape floating set learning resources big time clock. I don't know. This one maybe incorrect. Is anyone keeping score? How many have we gotten so far? I think it's like 3 wrong and 2 right. Okay, the Rockin' Rider, Giggles Baby, Rocker Ride On, or World of Eric Carle, Very Hungry Caterpillar gift set. Who thinks number 1? Who thinks number 2? I think number 2. All right. Oh, I was wrong. Really, Eric Carle yeah. I mean, I guess it's gone. I guess yeah, everyone knew. Okay, so the point is, I've done this. So these are all random ones, but this is kind of hard for me. I don't do very well at this, and this sort of is just the fact that this may be a really hard problem. Maybe we can't really know from just looking at this whether this is really possible or not. So I'm going to create a different version of the ranking game because I'm going to make the problem. This is sort of the debugging fact, right? Like I'm going to make this problem easier. And now I should really be very clear here. I'm going to make it easier in a way that's not really fair. That kind of is not really valid because we're never going to get data from this distribution. But just for the sake of argument, what I'm actually going to look at is, can I even tell the very highest rated items from the very lowest rated items. Because if I can't do that, I'm completely hopeless, right? There's just no way I'm going to succeed here. But if I can do that, then at least there's at least a difference between the best items and the absolute worst items. So I'm going to create another version of this game where I'm actually going to always select this one in the top half. So this would be length divided by 10. So this is always going to be in the top half. And then this one is going to be in that plus, this is always going to be in the bottom half. So the length of df divided by 10. Okay? So now we're going to have this, the IT1 always in the top half, IT2 always in the second half. Of course, this wouldn't be a very fair game because you just always would pick number 1, right? So I have to swap them. So rand is less than 0.5. Then IT1, IT2 equals IT2, IT1. Okay, so I'm going to swap them randomly. And everything else stays the same, I believe. Okay, so we still, are always, this is always, this one's lower, we always go with the lower one, etc. Okay, so let's call this ranking game 2. All right, so now let's play the ranking game 2. All right. Okay, so which of these do we think is one of the highest rated items and which is one of the lowest rated items for a baby? All right, who thinks number 1 is the right one? Who thinks number 2? I think number 2 also. Let's see. Ooh, I was wrong here. This is I'm off to a bad start. This one, okay. So Thomas the Train wooden 2-in-1 playboard or Harley Davidson developmental toy hog. Who thinks number 1? Who thinks number 2? It's $100. Yeah. This is hard because that one is $100. I still think probably number 1. Thomas the Train is really no. I'm off to a really bad start here. I'm usually good at this version. Okay, so who thinks the fishing toy is the good one? And who thinks who thinks the fishing toy? Okay, who thinks the other one? All right, I'm going to actually go with number 2. Okay, yeah. That one I had a good reason for thinking why that one was the case. Okay, let's see if I can do better. Mr. T, oh man, this has got to be the... okay, so who thinks the Toys of Wood Oxford sorting shape wooden clock with numbers and sorting blocks is the better one? And who thinks the Mr. T rubber ducky bath toy is the better one? This one actually, I admit, I'm going to say number 1 probably. The number 2, the Mr. T is just kind of weird. Okay, SpongeBob SquarePants Krabby Patty Wagon. Who thinks? And who thinks the ball, the beach ball? I'm gonna probably go with the let's see. So this one, yeah, I'm gonna have to go with this one. I think the ball is just a ball. Okay, let's keep going. A few more. The battery operated scuba toy. Who thinks that one? Who thinks the Fisher-Price Roller Blocks fire truck? I definitely think the fire truck too. Okay, so I'll keep doing this. I'm getting pretty good at this. So I think so penguin, rubber duck. I think it's probably this. It's gonna be definitely this one. Okay, this is. It happened again. It's random, so I can definitely do that one. But okay, so this one I probably think. Let's see. It's actually a tricky one, but I would probably actually say the Velociraptor. I'm going to guess. Okay, all right. So I'm actually getting. I'm again. And you have to get. It's whether or not an expert can do it. All right. And I consider myself an expert at kids' toys between the ages of 0 and 2. But I'm pretty good at this game here. I can definitely, and I've done this both in class. I was like. Got the first 2 wrong, so we're just making up for that the whole time. I think we got everyone after that. So we're doing pretty well on this. So the point is, this task is now possible, leading us to think that we at least can differentiate the very best things from the very bad things. So what we're going to do next time, this is actually taking a little longer than I thought, but we'll spend a lot of the next lecture doing it because I want to go through this in some detail. It'll probably take most of the next lecture. I want to go through now how do we set up a classification task on this problem and how do we analyze the data from these tasks to actually see how well we can do on this problem, both from text data and from visual data. And we'll wait till next time before I post this, the notebook and everything. Actually, maybe I'll post it now, but we'll get a lot more next time. And we'll continue on Monday. All right.